Good morning. So in this video we are going to discuss about the second method of network address translation, which is dynamic NAT. So in case of your dynamic NAT, it is also similar process like static NAT. So in case of your static NAT, we have a fixed mapping public address for every private address available in your network, right? So we have a pool of public IP addresses, and we have a usage of private addresses, and we have a static fixed individual public address for every private address in the available network, right, in the network. Whereas in case of this dynamic NAT, we have pool of IP addresses. There is no fixed public IP, right? So as per the demand, as per the packet transmission arrives at the router, it will assign whatever the public IP addresses available in the list, right? So that is what dynamic NAT is, right, which is not that much similar to which is not that much advanced and advantage technique in case of network address translation. But this is one difference between static and dynamic NAT is nothing but there in case of static NAT we have a fixed one single public IP for every public IP private address, whereas here the public IP may change, right? It has pool of public IP addresses, and when packet arrives, it depends on the availability of the public IP, it may change, right? First time one private address may have different public IP, and for next request, if the respective public IP is not available, it will be allotted with different public IP. So anyway, the public IPs is going to change, right? So that is what dynamic NAT is. So let's go for configuring the things. Let's have 3 PCs in the network, and I have a network device, a switch for connecting these devices, and I need to have a router, 2911 router, and let's go for another router, and I need to have a switch, and finally I need to have a server. Okay, let's go for arrangement of things in different manner. Okay, so let's define the connection as fast as possible, because video length has to be small, so that a lot of people are watching this video, at least to the fullest extent. So let's make as fast as possible, and let's enable the serial port connection. Always server to server connection should be of serial port. So switch off your router, take the serial connection and switch on your router, and similar process to be done here. Switch off your router, enable the serial port connection and switch on, and now choose the serial connection between the routers. Yes, it's done. So let's go for labeling. In this case, this is nothing but my let's go for rectangle, so that in this case it will be easy for us. I think the shape is not comfortable. Okay, let's leave. So for example, if you can like this, so that it will be easy for us to keep it as a private network, right? So I think now it's possible. Yes, so it's a private network, right? This is a private network. this is a public network. So what needs to be done here is I need to assign the IPs 192.168.0.1. Let's copy this. This has to be 2. This has to be 3, right? And this interface will have will be the IP for the gateway router, and this will have the same IP. We'll use the same set of IPs here. Okay, and let's keep the IP address for this is 200.0.0.1, and this is going to be 200.0.0.100, right? Let's copy this thing so that it will be easy for us to configure. So 100 is nothing but the default gateway. So 200. Is the default gateway. Let's configure the server. 200.0.0.1, 200.0.0.100. So default gateway. Okay, NPCs and servers configured. Let's go for configuring of things for gigabit Ethernet. It is going to be 192.168.0.100, which is nothing but the default gateway IP of this private network. Port state is enabled, and serial port 0, which has the IP of 11.1.1.1, and subnet mask will be automatically taken. Port state is enabled, and for this router, gigabit Ethernet 0 is going to be 200.0.0.100, which is nothing the gateway IP for public network, and for serial port 0 it is going to be 11.1.1.2. So all IPs configured right now, and what needs to be done, same process has to be done, except the things that is done. Okay, let's keep this like this. Okay, right, fine. So what needs to be done is here I need to do the same process. You need to define the default route. So IP route 0.0.0.0, 0.0.0.0 to 11.1.1.2, right, which is default route to your internet service provider, which is internet router. This, okay, it has to be 2. Okay, fine. And here the static route has to be defined. So static route is 11.1. It is because we are going to convert into 50 network, right? 0.0.1. Okay, and network ID has to be specified 255.0.0.0, and next stop is going to be 11.1.1.1, right? Yes. Static is also here the default default route has to be defined from your network router to internet service provider, and the static route has been defined from this router to your private network router, right? Okay, now NAT things has to be done. So you need to define which interface is inside NAT and which interface is outside NAT. So initially it is G0/0. So So this interface is going to be IP NAT inside exit, and SE0/serial interface, and this is going to be IP NAT outside. Yes. So this interface has been defined it as NAT inside, and this interface has been defined as NAT outside, right? Okay. And what other needs to be done here is you need to perform the dynamic NAT process, right? So in case of your dynamic NAT, in the previous case we have statement like IP NAT inside source static, and we have defined the respective public IP address for every replace the respective public IP address for every private address, whereas here we need to define it with some syntax, right? So here the first thing what you want to do is we need to define an access list. Access list is the list of private IPs, right? So access list, and any number you can give. Let's take 50, any number. This is going to be a representation, right? Permit is a keyword, right? Permit, and followed by the IP address, private IP address range, right? Network ID 168.0.0, right? And your subnet mask. So which means except the last byte, so rest of the ID. What does it mean is whatever the network traffic that comes from 182.168.0, right? So the entire this network has to be modified, right? So this last byte is going to be left out. So this whatever the traffic that comes from this network, this IP, so it is going to be processed by this translation, right? So this is what the access list is. This is nothing but access list. There is a keyword mismatch. Access hyphen list. Yes, after access list 50, it's a number, any number, permit. Okay, now it works. Okay, right, fine. And next you want to define the pool of public IP. The first statement is nothing but the private addresses you are going to use, and the second statement is nothing but the pool of IP addresses you have, right? Pool of public IP addresses you have, right? So IP NAT and pool, right? And you can give any name. Let's take public. So public IP, you can have it as, it's a understanding for your understanding, and you need to give the start address and end address. 50.1. 50.0. 50.0.0.1, and the end address is going to be 50.0.0.50, right? 50 PCs. Let's take 50 PCs, right? And you need to give the net mask, right? Subnet mask for this with the keyword of net mask 255.255.255.0. Right. Yes, it has taken. Now you need to map these. So the first statement consists of the private addresses, whereas the second statement consists of the pool of public IP, right? So private addresses will be represented like with the help of 50, and public addresses will be represented with the help of the name given, right, near to the spool, which is public IP. You can give any name, right? Any name you want, right? And the third sentence is going to be, third syntax is IP NAT inside source list. Here in this, all these are keywords. So source list, this 50 is going to be the source list, and the pool is going to be public IP, which I have defined it as a, right, this public IP. This 50 is nothing but the list of access list, and public IP is nothing but the name what you have given for the pool of public IP addresses, right? Now, yes, it has taken. So now all the process has been completed. So you can check for simulations. So let's go and check for simulation mode. I'm going to track only the ICMP packets. Okay, let's go for checking of the process. Let's go for first IP to server. Packet is ready to transmit. It reaches switch and it reaches router. Yes, router to router transmission taking place. Some error has happened. Something has left out. I think we haven't defined the interfaces, I think. Which is 11.1.1.2. Okay, right, fine. Is it right? Yes, let's check for one more time. Yes, now it works. It reaches server, and from server to switch it reaches router, ISP router, and from ISP router to our own private network router it comes to switch, and finally it reaches the source, right? So this is what. So let's go for checking of this process. Here it's we have defined this is one net 1.1 system, 0.2, 0.3 IP, right? So now this has been done. Look at when you check the first which is router to switch packet, router to switch. Yes, this packet has to be viewed. Look at the source IP is 192.68.0.2, and look at the next interface, which is nothing but the serial interface. Here it is translated. Source IP has been translated from this IP to 50.0.0.2, right? So in the available pool of IP addresses, public IP addresses, it has allotted 50.0.0.2, right? But let's go for the another simulation where the public IP will be different. So it's the same set of same PC and same server. The request, so it reaches server, transmission completed. If you take router to switch to router, right? If you take this packet, same time in the available port of IP addresses it is allocating. Let's go for parallel simulation so that I will have different set of IP addresses allotted. Okay, from same source, because to see different public IPs you need to have parallel simulations. Okay, all these will start. All the transmissions are completed. So if you take this switch to router packet, yes, this switch to router packet, here for 192.168.0.1 it has been converted to 50.0.0.2, right? And let's go for one more packet, switch to router. Yes, this packet, look at 192.60.0.2 will be converted as 50.0.0.3, right? So in the available public pool IP addresses, it will allocate some public IP for the request that comes, right? So that is what dynamic NAT is. So static NAT is defined with the same public IP for the respective private IP, whereas in this case it depends on the availability of pool of IP addresses defined. You need to have the Yeah, it will define this this NAT router will define the public IP for the available request, right? The request that has arrived, right? So we'll see next part in the next video, right? Thank you.